Welcome back to Baz AI platform for cutting-edge technological discourse. Welcome to our deep dive into the latest advancements in large language model, LLM, architectures. Today, we're exploring the structural innovations behind four cutting-edge LLMs prominent in 2025, DeepSeek v3, Kimi K2, Gemma 3, and OLMo 2. These models showcase how modern LLMs balance performance and efficiency through sophisticated techniques. Below, we'll break down their key architectural features using precise, domain-specific terminology, including multi-head latent attention, MLA, mixture of experts MO, sliding window attention, and RMS norm placement. Let's get started. DeepSeek v3 is a 671 billion parameter mixture of experts MO model released in December 2024 with its reasoning variant, DeepSeek R1, following in January 2025. Remarkably, it activates only 37 billion parameters per token, highlighting its efficiency. Multi-head latent attention, MLA. Unlike traditional multi-head attention, MHA, where each head independently computes key, value, and query projections, DeepSeek v3 employs MLA to optimize the memory-intensive key value, KV cache. MLA compresses key and value tensors into a lower dimensional latent space before storage. During inference, these tensors are projected back to their original dimensionality via an additional matrix multiplication. This approach significantly reduces memory usage compared to MHA. Ablation studies from the DeepSeek v2 paper indicate that MLA slightly outperforms MHA in modeling accuracy, measured by perplexity and downstream tasks. When compared to group query attention, GQA, which shares key-value pairs across query heads to save memory, MLA's latent compression provides both superior efficiency and performance. Mixture of experts, MO. DeepSeek v3 replaces the standard feed-forward network in each of its 61 transformer blocks with an MO layer featuring 256 expert feed-forward networks. Per token, only 9 experts are activated, 8 routed experts, and 1 shared expert, yielding an active parameter count of 37 billion. The shared expert manages common linguistic patterns, while routed experts specialize in tasks like coding or mathematical reasoning. This sparse activation strategy scales model capacity without proportionally increasing computational cost. Kimi K2, a 1T parameter MO model optimized for agentic tasks. Overview. Developed by Moonshot AI, Kimi K2 is a 1 trillion parameter MO model with 32 billion active parameters per forward pass. Released in 2025 as an open-weight model, it excels in agentic tasks like coding and logical reasoning. Architectural highlights. Kimi K2 adopts MLA for efficient KV cache management, akin to DeepSeek v3. However, it enhances its MO modules with a larger number of experts, potentially boosting task-specific specialization, and reduces the number of heads in its MLA module, refining attention granularity. These tweaks contribute to its strong performance on benchmarks like LiveCodeBench and ZebraLogic. Unlike its predecessor, Kimi 1.5, Kimi K2's open-weight status has made it a cornerstone of the open-source AI community. Google's Gemma 3, a 27 billion parameter model, prioritizes efficiency with sliding window attention. Available in multiple sizes, it supports multilingual tasks with a large vocabulary and thrives in resource-constrained environments. Sliding window attention. Departing from global self-attention, Gemma 3 restricts each token's attention to a local context window of 1,024 tokens, down from 4096 in Gemma 2. It uses a 5-to-1 ratio of local to global attention layers, 1 full attention layer per 5 sliding window layers, reducing the KV cache size significantly with minimal perplexity loss, as per the Gemma 3 technical report. It also incorporates GQA for additional computational efficiency. Normalization layer placement. Gemma 3 employs RMS norm in a hybrid pre-norm and post-norm configuration around its GQA module. This contrasts with the pre-norm of GPT-2 or the post-norm of OLMo 2, balancing training stability and performance for its localized attention focus. From the Allen Institute for AI, OLMo 2 is an open-source model emphasizing transparency and reproducibility. While not a performance leader, its detailed documentation offers valuable insights. Normalization innovations. OLMo 2 uses RMS norm, a streamlined layer norm variant, in a post-norm configuration after attention and feed-forward modules within residual connections, unlike the pre-norm of Llama or GPT-2. It also introduces QK norm, applying RMS norm to queries and keys before rotary positional encoding in its MHA module, enhancing training stability in deeper architectures. A later 32B variant adopts GQA for efficiency. In 2025, LLM architectures evolve through subtle yet impactful refinements. DeepSeek v3 and Kimi K2 leverage OLMo and MLA for scale and efficiency in reasoning and coding. Gemma 3 optimizes for local deployment with sliding window attention, while OLMo 2 emphasizes stability and transparency via innovative normalization. These advancements highlight how sparse activation, attention compression, and strategic normalization enhance the foundational transformer architecture.